Hello, juniors. Today we're going to see the last part corresponding to electronic assignment number 18, which is forms of quadratic functions. If we make a quick review of what we did during the past classes, remember we've seen the two out of the three different forms of equation of a quadratic function. If you remember, the three are these ones over here, which are the vertex form, the general form, and the factorized form. If you remember, the vertex form has this form where f of x is a times x minus h squared plus k, where h and k represent the coordinates of the vertex of the parabola, and a is important for us to determine whether the parabola opens upward or downward. Then we have the general form, which is the one we saw last class, which is f of x equals ax squared plus bx plus c. Remember, the general form is also known as the standard form. And in this case, a has the same meaning as in the previous form. The value of a tells us whether the parabola opens upward or downward. Then the value of b doesn't have a direct representation, but it is used to determine the axis of symmetry in the vertex. Remember, the axis of symmetry has equation minus b over 2a. And then with this value, we can find the vertex by plugging in the x coordinate into a function and finding the y coordinate, if you remember that from last class. Okay, so that's why the value of b is also useful in the general form. And finally, the value of c tells us the y-intercept of the graph. That is where the graph crosses the y-axis. So today we're going to center in the last case, which is the factorized form, also known as the x-intercept form. And we're going to see what each of these parameters represent. So let's go down. We already did all of this. So this is the factorized form, also known as the x-intercept form. X-intercept form. This is another name for this case. And you see it's f of x equals a times x minus p times x minus q. So it says, for the graph of a quadratic function, y equals f of x, the x-intercepts are the x values where y equals f of x equals 0. So when we talk about the x-intercepts, we're referring to the point where the graph crosses the x-axis, okay? And for those values, the value of y is always 0, right? If you look at this graph over here, the x-intercepts are this point and this point. And in both cases, the value of y is 0, okay? That's what we know as x-intercepts. So it says, writing a quadratic function in factorized form allows us to easily find the values of x for which f of x is 0. So that's the usefulness of this form. It says, a quadratic function which is written in the form f of x equals a times x minus p times x minus q, where a is different from 0, is said to be written in factorized form or intercept form, as I told you. The coordinates of the x-intercepts of the graph are p0 and q0. Here, f of x is written as the product of three linear factors, a, x minus p, and x minus q. If you notice, here we have three products, right? A, let me do this in a different color. A is a factor, x minus p is another factor, and x minus q is another factor. Why is that important? Here it says, if f of x is 0, only when one or more of the three factors itself equals 0. Since a cannot be 0, because we defined a as a number different from 0, the other alternative is that either x minus p, the first factor, is 0, or x minus q is 0. So, if we solve for x, we would take the p to the other side, we would get that x equals p, and in the other case, we would get that x equals q. So these two values represent the x-intercepts of the graph, right? Because just to make this clear, if I set a times x minus p times x minus q, if I set this to 0 in order to find the x-intercept, let me write that here. X-intercept means that y is 0. And y equals 0 is the same as saying f of x equals 0, right? So we set this to 0, and we get, wait a second, f of x equals 0. So then if we set that to 0, we would get 0 equals a times x minus p times x minus q. But so these are three factors, right? A is one factor, x minus p is another factor, x minus q is another factor. So if a is different from 0, that means that only this factor or this factor may be 0 in order to produce this 0 in the other side, right? So that's why we get two results. One possible result is that 0, let me do that here, 0 equals x minus p. So here we get that x equals p. And in the other possible case, 0 equals x minus q. So that's why x equals q. So those are the two x coordinates of the y-intercept, right? The first one would be p comma 0, and the second one would be q comma 0. Okay, that's what we're shown here. So p comma 0 and q comma 0 are the x-intercepts of the graph y equals f of x. You can also find the equation of the axis of symmetry from the factorized form. Due to the symmetry of the parabola, the axis of symmetry will pass through the midpoint between the x-intercept. This is a very important concept. If you watch this sketch of a parabola I did here, you will see what is explained in the paragraph. You see that we have the first x-intercept and the second x-intercept. Always, the x-intercepts will be symmetrical with respect to the axis of symmetry of the parabola, right? Because remember, the axis of symmetry divides the parabola into two symmetrical or identical shapes. That means that the distance from the first x-intercept to the axis of symmetry should be the same distance from the second x-intercept to the axis of symmetry. Okay, so in order to calculate, if we know both x-intercepts, we could calculate the axis of symmetry by finding the midpoint between the two x-intercepts, right? So the midpoint would be p plus q divided by 2. It's like finding an average, right? That's the midpoint. So the axis of symmetry can be found using this small equation we have here, p plus q divided by 2. And that's what it's explained in this box over here. If the x-coordinates of the x-intercepts are p and q, then the equation of the axis of symmetry is x equals p plus q divided by 2. And the vertex of the graph, remember, this is the equation of the axis of symmetry, and at the same time, it's the x-coordinate of the vertex. So in order to find the y-coordinate of the vertex, we just need to plug in this value of x into our function, and we would get the y-coordinate, just as we did with the general form of the quadratic equation. So this is how we calculate the axis of symmetry. This is how we calculate the vertex. Remember, we did the same thing for the general form, but the formulas were kind of different because we had different values. This is the case for the general form of a quadratic function. To find the axis of symmetry, we apply this formula, and to find the vertex of the parabola, we apply this formula over here. Okay, so there's a little bit of a difference between these two forms. But if you understand what each of the letters represent, then this is very easy to distinguish. Okay, so let's see the example. I think this is the last part of this electronic assignment. It says, find the equation of the axis of symmetry and the coordinates of the x-intercepts, the y-intercepts, and the vertex. So now we're asked for all of the different characteristics of the parabola. Use these features to sketch the graph of the parabola. Okay, so remember, the factored form of a parabola is f of x equals a times x minus p times x minus q, where a tells us if the parabola opens upward or downward, p and q are the x-intercepts, or also known as roots of the quadratic function. Okay, so in part A, we first need to find the axis of symmetry. How do we calculate the axis of symmetry if we're given the function this way? Remember, from this concept we saw here, the axis of symmetry is the midpoint between the two roots, which are, what are the two roots in this case? What will be the value of p? The value of p is 4. Pay attention that the negative is part of the formula, so it's positive 4. And q is positive 2, right? So the axis of symmetry in this case would be, remember always to write x equals something, and it will be x equals p plus q divided by 2. Let me write it as p plus q divided by 2 first, and then we're going to apply the values. So this would be x equals 4 plus 2 divided by 2. This is 6 divided by 2, and this equals 3. So the axis of symmetry, the equation of the axis of symmetry is x equals 3. Then we want to find the coordinates of the x-intercepts. The x-intercepts, we already have them. They are 4, 0, and 2, 0, which are the roots of this quadratic equation. So I'm going to write them here. I don't know if I will have enough space, though. Let me see. Maybe I can drag this up there. Here. I'm going to take this up. Here. So, x-intercepts. The x-intercepts, they are 2. Remember, it's always, I'm going to put it like this. 2 points, p comma 0 and q comma 0. So in this case, this would be equal to 4 comma 0 and 2 comma 0. Those are the two x-intercepts. Remember, these are points, so you should always write the x-coordinate and the y-coordinate. Then we want to find the y-intercept. How can we calculate the y-intercept when we're given this form of the quadratic function? To find, let me do it here. To find the y-intercept, we would have to distribute this or expand this equation. So we would have to do the distributive property or FOIL method in order to pass this to the general form of the quadratic function, and then we will be able to identify the y-intercept. So this would be x squared minus 2x minus 4x plus 8. So finally, this is f of x equals x squared minus 6x plus 8. So you see that this is already written in the general form. And if you remember, in the general form of a quadratic equation, the independent term represents the y-intercept. So the y-intercept, which is where the function crosses the y-axis, the y-intercept will have coordinates 0, 8. Remember, the x-coordinate is always 0 when we talk about the y-intercept. Okay, so there we have the y-intercept. Then we need to calculate the vertex. That's the last part. I think I'm gonna have to take this down. Oop. Let's take this down. There. And there. Okay, so I can gain some space there. So, for the vertex, to find the vertex, I already have the x coordinate, which is the same as the x-axis, which is 3, x equals 3. But I still need to find my value of y. To find my value of y, I can replace the x value into the function. So this would be f of 3. Okay, so I calculate f of 3. That is, I plug in this into the equation. And this would be 3 minus 4 times 3 minus 2. And if we do this, this gives us 3 minus 4 is negative 1. Negative 1 times positive 1 is negative 1. Negative 1. So the vertex has coordinates 3, negative 1. That's our... With this information, we have all of the requirements to make the sketch of our parabola. Okay, so I'm gonna see if I can make it. I'm gonna divide this right here. So I'm gonna make the sketch for part A right over here, down here. So we know that the axis of symmetry is 3. The roots are 4 and 2. Both are positive numbers. The y-intercept is 0, 8. That's a positive number 2. And the vertex is 3 and negative 1. That means that our smallest value would be a negative 1. So if we make our coordinate plane, we could do something like this. I'm not using too many negative numbers, so I could just leave it like that. This is x, this is y. So this is 1, 2, 3, 3, 4, 5. 1, 2, 3, 4. And down here we can add negative 1, which is the only one we would need. I could write here negative 1. So let's plug in the points. The vertex 3, negative 1, that's over here. Then the y-intercept 0, 8. Ooh, I'm missing 8 here. I will have to extend this up until 8. So this is 5, 6, 7, 8. 8, 7, 6, 5. But remember, this is a sketch, people, so you don't need to be that precise, but I'm just showing you this so you can understand this better. Okay, so 0, 8 is the y-intercept, and then we have the roots, which are 4 and 0, that's here, and 2 and 0, that's here. And then we have the axis of symmetry, which is x equals 3. That's a vertical line at x equals 3. I'm going to erase this part of the line. There you go. So now that we have these points, we can draw this by hand, and we will get our sketch of the parabola. We just do it up to there. If you want, you can extend this, making it symmetrical to the other side, something like that. And you get the sketch of the parabola for part A. Okay, so that's it. Then we have part B, which I'm gonna make the division here. Okay, so for part B, we will do the same thing. F of x is negative 2 times x plus 3 times x plus 1. So the value of, let's first write the general form, a times x minus p times x minus q. This is also given in factored form. A is negative 2, p would be -3 in this case, -3, and q is -1. Remember, it's always the opposite sign as the one you see there. So this is -1. Okay, once we have A, P, and Q, we will find the different things we're asked to find. First of all, the axis of symmetry. The axis of symmetry. If we follow the same process, this is P plus Q. I'm going to write it down here. X equals P plus Q, -3 plus -1, P plus Q divided by 2. And this is -4 divided by 2, this is -2. So this is the axis of symmetry. Then we want to find the x-intercepts, which are the roots. Remember, it's P0 and Q0. So the x-intercepts are, in this case, -3, 0, and -1, 0. These are my two x-intercepts. Then we need to find the y-intercept. To find the y-intercept, once again, I need to expand this product, and we would get, let me see, I'm gonna do it here. F of x equals -2 times x plus 3 times x plus 1. If we expand this using FOIL method, we would get -2 times x squared plus x plus 3x plus 3. And then if we distribute the -2, we would get -2x squared minus 2x. Sorry, we can add these two terms here. So this would be positive 4x. Positive 4 times -2 is -8x minus 6. So this is written in general form, right? So the y-intercept is the independent term over here. So the y-intercept has coordinates 0, -6 in this case. So now we have the y-intercept. Finally, we need to calculate the vertex, right? For the vertex, we already have the x-coordinate, which is -2. So this is -2, and the y-coordinate would be f of -2, whatever the function is for x equals -2. So f of -2 is, if we follow our function, this one, -2 times -2 plus 3 times -2 plus 1. If we do this product, this gives us 1. 1 times -1 is -1 times -2, this is +2. So the vertex has coordinates -2, 2. That's the vertex. Okay. Once we have all of the different characteristics of the parabola, we would make the sketch. You see that in this case, the value of a is negative. So we should get a parabola that opens downward, right? So let's see if we get that. The y-intercept is -6, and then the vertex is 2. So the maximum value is +2, the minimum value is -6, and then the x-intercepts are both in the negative side, and it goes up to -3. So I'm gonna make my coordinate plane like this. I'm gonna do it right here to have space. No, I'm gonna take it a little bit more over here. It'll be concentrated in the negative side, so it's better if I do it this side. So this should go up to -6. So, and the greatest value is +2. So this is 2, 1, 0, -1, -2, -3, -3, -4, -5, and -6. We can extend this right down. This is y, and this would be our x. This is a little bit ugly. Oh. There you go, x. So this is 1, and this is -1, -2, -3, -4, and so on. Okay, so let's first plot in the vertex, which is -2, 2. That's right over here. Then we have the x-intercepts, -3, 0, that's here. And -1, 0, that's here. Then we have the y-intercept, which is 0, 0, -6, that's right here. And finally, the axis of symmetry at x equals -2 is right over here. So as you see, if we join these points by hand, we will get a parabola that faces downward, which is what we were supposed to get, right? We can extend this symmetrically to the other side, and there is our parabola, okay? So this is how we quickly sketch a parabola, having the important characteristics, which are the y-intercept, the x-intercept, the axis of symmetry, and the vertex. Finally, before we finish, we're gonna make a brief summary of all of the different forms of a quadratic functions we've seen during these days. Here's a reflection question before. It says, what is the largest possible domain of a quadratic function? What is the range of the function y equals a times x minus h squared plus k? If you think a quadratic function, the largest possible domain is all real numbers, right? Domain, all real numbers, because it does not have any restriction for the x values. So the domain, the largest possible, are all real numbers. And for the range, we would always have to pay attention at the vertex, right? It's either from the vertex towards infinity up, or from the vertex towards infinity down, right? So towards negative infinity. So it depends on whether the parabola opens upward or opens downward. So the range would be from k would be the y-coordinate of the vertex, right? So if a is positive, if a is greater than 0, that means that the parabola opens upward. That means that the vertex would be a minimum. So the range in this case would be y greater or equal than k, right? That'll be our range. But if a is less than 0, that's negative, the parabola would open downward. So we will have a maximum point over here. And that means that our range would be y, it's right. Y is less or equal than k, okay? So it all depends on the sign of a for us to be able to determine the range. Okay, finally, the summary. It says, a summary of the relationship between the parameters of a quadratic function and key features of the graph of the function is shown in the table. This is very important for you to remember, people, and this is not in the formula booklet, so you will have to learn this. If you really understand what each of the parameters represent, this is very easy. Okay, so the first form is a general form, f of x equals ax squared plus bx plus c, where a is different from 0. The y-intercept is directly found by looking at this value. The axis of symmetry is calculated by doing minus b over 2a. And finally, the vertex is calculated this way. The x-coordinate is the same as the axis of symmetry, and the y-coordinate is calculated by plugging in this value of x into the function. Then we have the vertex form, which has this form, a times x minus h squared plus k, where a is different from 0, and the axis of symmetry is x equals h, this value over here, and the vertex has coordinates h for the x-coordinate and k for the y-coordinate. So this vertex form tells us the vertex directly. The general form tells us the y-intercept directly. Finally, the intercept form or factored form is f of x equals a times x minus p times x minus q, where a is different from 0, And the x-intercepts or roots of the equation are p0, which is this value over here, p comma 0, and q comma 0, right? And the formula for finding the axis of symmetry is the midpoint between both x-intercepts, so this is p plus q divided by 2, and the vertex is found by plugging in the axis of symmetry, and plugging in that value of x into the function in order to get the y coordinate of the vertex, okay? So the intercept form tells us directly the x-intercepts, right? P0 and Q0. So when do we pick what type of function? It all depends on what we want to find. If we want to find the y-intercept, this one's better. It's easier. If we want to find the vertex, this one is better. And if we want to find the x-intercept, this one is better than the other two. Okay, so this is just a summary of, once again, it repeats what we just saw here. So I invite you to pause the video and read this by your own, and you'll see that this just says the same thing, okay? So during the following classes, you will be doing exercises about this for you to be able to ground these concepts. And as always, if you have any doubts, you can always ask them through Google Classroom, and I will be available and I'll answer you back as soon as possible. So I hope you're doing fine, juniors, and have a great rest of the day. See you.